Good morning, children. So welcome to today's chemistry class. Today we are going to be discuss about the D block elements and writing of their electronic configurations. So what is today's topic? D block elements. First let us say about the definition of a D block elements. Okay, D block elements are nothing but if the differentiating electron enters into the d orbital, those elements are called as d block elements. So what is meant by differentiating electron? Differentiating electron is nothing but newly entering electron is called as a differentiating electron. Okay, so because of that newly entering electron, only one atom is different from the other atom. So that's why that electron is called as a differentiating electron. And if the differentiating electron enters into the d orbital, already we know that we have the four types of orbitals: s orbital, p orbital, d orbital, and also f orbital. So if it enters into the d orbital, those elements are called as a d block elements. So it is a definition of a d block elements. Now let us see the classification of d block elements. Here d block elements classified into four series of elements, four types of series of elements. One is an 3D series, and the next one is 4D series, and the next one is 5D series, and the next one is 6D series. Here the D block elements are again classified into four types: 3D series, 4D series, 5D series, and 6D series. Each series contains 10 elements each. So here 6D series is incompletely filled. Incomplete by the elements, or incomplete by the elements are incompletely filled. So here the 3D series is present in the fourth period, and the 4D series is present in the fifth period, and 5D series is present in the sixth period. So what is the period here? Already we know that in the new periodic table. So in the modern periodic table, we have the 7 horizontal rows. Those rows are called as periods. So 3D series is present in the 7th horizontal row. So that is called as fourth period, and the 4D series elements are present in the 5th period. 5D series elements are present in the 6th period, and 6D series of elements are present in the 7th period, and it is incomplete. Already we know that the 7th period in the modern periodic table is incomplete. Okay, so it is about the series of elements, and each series is filled by the 10 electrons. 10 elements. Why only the 10 elements are present means here d orbital is again subdivided into 5 degenerate orbitals. D orbital is again subdivided into 5 degenerate orbitals. Those are dxy, dyz, dzx, dx square y square, and dz square. So each orbital is filled by the 2 electrons. When we fill the electrons, that means the maximum number of electrons filled in the d orbital is 10 electrons. So that's why each series contains 10 elements each. Okay, now let us see the 3D series elements. The 3D series elements are present from scandium to zinc, and the atomic number of scandium is 21 and the zinc is 30. So 3D series elements are ranging from 21 to 30. That means atomic number 21 to 30 are belongs to 3D series elements, and that is nothing but scandium to zinc. And the 4D series is from yttrium to cadmium. 39 to 48, and the atomic number is 39 to 48. And the 6D series is from lanthanum, hafnium to mercury. So 57, 72 to 80. Okay, so it is about the 3D, 4D, and 5D series elements. Now let us see what are the elements present in the 3D series and how we can write the electronic configuration for 3D series of elements. So before writing the electronic configuration, what is the valence shell electronic configuration for D block elements is n-1 D 1 to 10 ns 0 to 2. Why I wrote here 0 to 2 means, so commonly we can write it as an ns 1 to 2, but here Why I wrote 0 to 2 means in d blocks elements, some elements does not contains electrons in the s orbital. So that's why I wrote here ns 0 to 2. ns 0 to 2. Okay. So n minus 1 d 1 to 10 ns 0 to 2. So this is called as a valence shell and it is called as a penultimate shell. Valence shell and penultimate shell. Okay. Now let's see the elements which are present in the 3D series. Okay. 3D series. So in 3D series 10 elements are there. Those are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. And the atomic numbers from 21 to 30. 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. Now let us see how can we write the electronic configuration for scandium. So to write the electronic configuration of scandium, the atomic number of scandium is 21. So we can write as an based on the molecular diagram. So with the help of a molecular diagram, we can write the electronic configuration. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. This is the electronic configuration of scandium. So here 1s2, 2s2, 2p6, 3s2, 3p6. Up to here, when we count the electrons, number of electrons present up to 3p6 from 1s orbital to, so it is 18 electrons. So 18 electrons is nothing but it is the atomic number of argon. That means instead of writing this total electronic configuration, so we can write argon. Simply we can write argon. And where we can, that means there is no change in the electronic configuration of all d block elements up to 3p6. So that's why simply we can write argon. And where we can observe the change means so in the 4s orbital, that means in the s orbital which is present in the fourth shell, and the d orbital which is present in the third shell. Okay, that means valence shell and also the penultimate shell. Now let us see here. So scandium electron, how we can write the scandium electronic configuration means argon 4s2 3d1. 4s2 3d1. And the next one is titanium. For titanium also argon 4s2 3d2. See here argon is 18. 18 plus 2 20. 20 after how many electrons are remain? Only one electron, that should be filled in the d orbital. Next for titanium also argon 18. 18 plus 2 20. 20 plus 2 22. Next for vanadium we can write argon. So 4s2 3d3. And for chromium we can write argon 4s1 3d5. 4s1 3d5. And for manganese, so argon 4s2 3d5. Here we are not changing the total number of electrons but just we are observing the difference, the presence of number of electrons in the s orbital and also the d orbital. See here argon is 18. 18 plus 1 19. 19 plus 4 24 only. That means total number of electrons present in the present in it is equal to its atomic number. And iron electron configuration is argon 4s2 3d6. And for cobalt argon 4s2 3d7. And for nickel argon 4s2 3d8. And for copper 4s1 3d10. And for zinc argon 4s2 3d10. So it is an electronic configuration of 3D series of elements. So scandium 4s2 3d1, titanium 4s2 3d2, vanadium 4s2 3d3, chromium 4s1 3d5, manganese 4s2 3d5, argon 4s2 3d6, cobalt 4s2 3d7, nickel 4s2 3d8, copper 4s1 3d10 and zinc is also 4s2 3d10. So it is a writing of an electronic configuration of 3D series elements. Now let us see the trick how we can easily remember the writing of an electronic configuration of these 3D series elements. So here the number of electrons present in the d orbital is 1 to 10. So first write that 1 to 10 number of electrons here. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, these are the, what are these numbers? These are the number of electrons present in the D block elements in the 3D series. Okay, now we have to write, for 1 we have to write 1, that means for 2 also there is no change, for 3 there is no change, for 4, so we can't write 4 number here, so instead of 4 what we have to write here? 5. The next 4 after 5 will come, no? So we have to write 5. Next for 5, 5, 6, next 7, next 8. For 9 also we can't write 9. So for 9 we have to write 10, and for 10 also 10. See here, so there is no difference. That means 1, 1, 2, 2, 3, 3. And for instead of 4 what we are writing? 5. When we are writing 5 means in the s orbital contains only one electron. So we should write 4s1 3d5. Next 5, 6, 7, 8. Instead of 9 what we are writing? 10. Whenever you are writing 10 in the d orbital of copper means, so we should write only one electron in the s orbital of the fourth shell. And for 10, 10. So if you remember this one, that means what the numbers we do not write means 4 and 9 for the 3D series. So for the 3D series we should not write 4 and 9 number of electrons in the d orbital. If we remember that one, then easily we can remember we have to write the next number as 5 and 10. Okay, so after filling of an d orbital we can fill the remaining electrons in the s orbital. So this is the way to write the electronic configuration of d block elements, especially the 3D series. Okay, I hope you all understood the today's class. Okay, thank you for watching.